Hello everyone, in this video I'm going to show you how Haystack Dependency Injection version 3.0.6 works in Unity, step by step. Haystack is a dependency injection framework for Unity that helps us keep our project cleaner, easier to manage, and more scalable. It supports different injection flows such as direct injection, indirect builder injection, manual bind and resolve, collider injection, and even static injection. Before we begin, let's quickly understand the idea. Dependency injection means that instead of a script manually finding or creating its required references, those dependencies are installed and then injected automatically where needed. In Haystack, the main attributes are install for registering a dependency, inject for receiving a dependency, Haydirect class for scene-based install and inject passes, Hayphysics class for collider-based injection, Hayinstalling method for logic before installation, Hayinjected method for logic after injection. In this latest update, Haystack Dependency Injection is now more optimized and better suited for heavy Unity projects. Next is indirect builder injection. Use this when the dependency source changes at runtime. You want to inject using a custom key. You have multiple variants like Player 1, Player 2, Enemy Type A, Enemy Type B. Step 1. Install with a custom key. Step 2. Inject using the same key. Here, the dependency is installed with a custom key, then injected, only when that exact key is requested. This is very useful for runtime switching and key-based dependency control. Haystack's runtime helpers explicitly support indirect Haybuilder install all and indirect Haybuilder inject all for this workflow. Now let's move to one of Haystack's special features, collider injection. This is useful for triggers, overlap detection, pickups, collision-based gameplay, combat systems. Haystack also supports collider 2D injection. Why this is useful? This makes interaction-based dive very powerful for gameplay systems like damage, pickups, and triggers. The doc specifically described collider and collider 2D flows as gameplay-aware injection paths. Next, let's discuss unbinding. Sometimes you want a dependency to be consumed only once. Attribute-based unbind after injection. Manual unbind. Collider unbind. Unbinding affects the exact binding slot based on dependency type, inject key, and custom key. If that slot is consumed, you must bind or install it again before expecting another injection from that same slot. And that's the basic workflow of Haystack Dependency Injection. As you can see, Haystack gives you multiple ways to register and inject dependencies depending on your game's needs. Whether that is scene-based, runtime-based, key-based, manual, or collider-driven. That's all for now. See you in the next video.